Hello, in this video we're going to talk about what is Kubernetes and what are its uses. So let's say we have an application, app 1, and to run this application we need it to be deployed on a machine. So we deploy it on a physical machine. In this scenario, if the application misbehaves, it can make the machine unstable and eventually take down the machine. So this may cause the machine to reboot or shut down the machine. Somebody have to go in and physically restart this machine. So to avoid this, we use the container technology using the Docker containers. We have the application running in a container and container running in a Docker engine and on a physical machine. With this setup, if the application misbehaves, it takes down only the container, does not disturb the machine, and does not disturb other applications that are running on the machine. This makes the machine available and the other applications available, and it only disturbs the one application which misbehaves. So this is good for now, but what if this application goes down, a person have to go in, log into the machine and restart that container. So how can we make sure that this application stays up all the time rather than somebody going in and restarting when it goes down? So that is one issue with this container. The other issue is if a container is up, when we want to connect to the container, we use an IP address to connect to the container from outside. And if the container goes down and we bring the container up, then the container gets a new IP address. And that means that the external client who was accessing the container or the application before now has to know about this new IP address. So which means there has to be two-way communications where we tell the client, well, this container was up and now it is down and came back up again, and this is the new IP address. And that sounds like a not nice of a solution. So how do we get around this? And that's what Kubernetes is going to help us. So let's take a look at this again. App 1 server running in a container, running in a pod. So what is this pod? Pod is a smallest building block of Kubernetes. So Kubernetes considers every application and it runs the application in a container, and each container runs in a pod. You can have more than one container running in a pod. A set of containers will define an application or a group of applications working together, and you can put that in a pod, or you can have only one application run in a pod in that one container, as you can see here. So the pod is running and the Kubernetes is going to be the process which will make sure that the pod is up all the time. This application misbehaves and bring the container down, then the pod comes down, Kubernetes gets aware of it, and it says, okay, I need to get this pod up, and Kubernetes brings the pod up again. Because as part of the configuration of the Kubernetes, we have identified that we need one pod to be available all the time. And Kubernetes makes sure that that is available all the time. You can have a configuration where you can say the pod is up all the time, and you can say I want 10 pods instead of one pod. That way you will have 10 pods running and 10 instances of your application running all the time. And how about accessing this pod? So for accessing this, Kubernetes have a service concept where external clients do not access the pod or the container or the application directly. They access the service. They come to the service, and the service will take them to the pod, and pod will take them into the application. So what happens with this is if the pod goes down, Kubernetes brings up the pod and it will make sure that the application is still pointing to the new pod, which has a new IP address. So instead of letting the client know where the service is or what the new IP is, Kubernetes is decoupling that and buffering it at the service level. So now if I have another instance running, the app service will run the request to either of these containers and make sure these two containers and the pods are up all the time. And that is what Kubernetes provides. So there are two issues that we saw here. One is to make sure the pod is up or the application is up all the time, which Kubernetes is going to keep an eye on, and making sure that pod, if it becomes unhealthy, the pod will restart or we get a new pod. And once it gets a new pod with a new IP, Kubernetes is making sure that IP list that it has with the service is updated. That way, for the user, whether the pod goes down or not, it's very transparent. The service is available all the time. So if we look back, the physical machine concept and the Docker container concept, those are giving us low availability where the application will go down until somebody brings it up, the application will stay down. But in case of Kubernetes, we will get a highly available system where it's up all the time. So that is one of the benefits of Kubernetes, of having an application highly available.